Okay, if you were absent earlier in the week, we went over the concepts of exponential growth and decay. And the way we introduced this was with these two examples that treat this in sort of an intuitive way. This first example, a doctor prescribes 400 milligrams to treat an infection. Each hour following the initial dose, 85% of the concentration remains in the body from the preceding hour. So, if we think about the first hour, there's 400 milligrams because the dose has just been given. But then after the first hour, we need to take that number and times it by 0.85 so we get 85% of what we had previously. And that then gives us that value 340 that tells us how much of the medicine is remaining in the patient's blood. So then when we go to find the amount that's in the body for the next hour, we need to take this 340 and times that by 0.85. But sometimes in math it's a little bit better to look at what's happening and not simplify till the end. So this number is 340, right? Because that's what produces 340. But then that is the same number that is here. So take 340 times by another 0.85, and that'll give us our next answer. So if we do that, and go down, and we'll fill this out in a minute, I'll show you how to fill it out really quickly. If we fill this out and figure out what the pattern is, each of the successive rows is found by taking what we have from the previous row, right? That's from this row, and it appears again here. Taking what's from the previous row, getting that value, and then multiplying that by another 0.85. Right? So each row we're multiplying by another 0.85, so we can take this information and draw some conclusions based on how the pattern shakes out. This is the same thing as 0.85 to the first multiplied by that initial value, 0.85 to the second, to the third, and then it would go on. And we could figure out these values very simply if we used a calculator and typed in our function, which if we try and figure out our function, for here we had our specific hours, and then we can get the specific values. But for my actual number of hours, if I didn't know if it was just a number of hours t, then 400 times 0.85 to the power t. That is what the expression is that would help make the function that determines all these other values. If in my equation I typed keeping in mind when we use a calculator we have to use x. If I type that in, I would, of course you're not going to see it unless you zoom because it's way up there at 400, but if you look at a table, then you will get those values that would be going in to this column over here, right? We start out with 400, then 340, which is what we see, and then we'd fill out the rest of the values. Now, answering the questions below, Problem 2, write a function a of t which describes the amount of medicine in the body after t hours. Well, the amount after t hours, this is sort of like an f of x type of thing, is given by 400 times our 0.85 to the power t. And just an aside here, we know that from this each hour, 85% of what was before remains, which means 15% is gone. Okay, 15% is decreasing. So think about what it tells you stays and then what naturally is disappearing as a consequence. As time approaches infinity, what amount of medicine will remain? Well, it's going to approach zero. You're never going to be completely free of it, but as the time, right, as our x values get bigger and bigger and bigger, we figure out what is happening to our y values. They just continue to decrease on down. They never quite get to zero, right, because we never actually get completely to zero, but that is the value that our function approaches. Number 4, determine the amount of medicine left in the body after 10 hours. Here I'm telling you on number 4 that t is equal to 10. So we need to take that 10, plug it into our function, and when we do that, 400 times the 0.85 to the power 10, even if we look at our table here, you're going to get 78.75. Okay, so 78.75 milligrams is what is left. Number 5, it says create a table. Look, there's the table. After how many hours will the amount of medicine in the body first be below 60 milligrams? Well, again, if I scroll down, first place where it's below 60 is hour 12. The second example is pretty similar to the first, except instead of having something going down, I'm telling you that the money is growing at 5% per year. So each year, like we started out with 400, we need to multiply by 105%, or 1.05, to get the value for the next year. So 400 times 1.05, and then again, same process. This value is what appears here, right? That is the number 420, and then we take that 420, multiply it by the 105%, the 1.05, and we get our new value. So same idea as what we did on the previous problem when we were typing our function. It's almost the same, it's just that 0.85 changes to the 1.05. And we get our updated list of values. So I'd continue this pattern on. We notice how the exponents again increase. So at the bottom row for this, I would have 400 times 1.05 to the power t, right? Because we don't know exactly how many years have passed at this point. And then there would be nothing written in this row because what is there to say as soon as you have the equation? Once again, your function down here at the bottom, you're going to have a of t equals that initial value 400 times your 1.05 to the power t. As t approaches infinity, will the amount of money in the bank account approach any specific value? It will not, because if we think about all these values as they go up, they're going to get to the point where they're going to increase without bound, right? You keep taking successive 105% of each number, and your numbers are just going to blow up and up and up and up. So, no. The values increase without bound. Or without a boundary, or without an upper limit. It just keeps going up and up forever. Determine the amount of money in the account after 10 years. Again, you just type that, plug in a 10, or type it in your calculator. To the power 10, type it in, and you're going to get a value, according to the calculator, of $651.56. Number 4, what is the first year in which the account will have an amount of money in excess of $600? That means above 600. Looks like the first year that happens is year 9. So we went from 590 to 620, so year 9. So that was it for the front page. And I'm going to put the next part of the notes in a separate video.